Hi, this is Mr. Boughton. I just want to go over lesson 3.7 very quickly in your textbook. This is on simplifying expressions. And before I jump into this right here, I want to go over the word terms because you're going to be using this a lot in this lesson. This lesson is all about recognizing terms. So before we do that, what are terms? So an example right here, this is an expression. If you remember from previously, terms can be found by looking for addition and subtraction symbols and knowing that addition and subtraction separates terms. So what I always encourage kids to do is just mentally draw a wall wherever you see addition and subtraction, unless it's in grouping symbols. You never want to split up things in grouping symbols, but otherwise put little walls there. Those walls separate terms. So I see a term right here, 7 times x times y squared, that's a term. 4 times x is a term, and 5 is a term as well. So there are 3 terms in this example right here. And while we're at it, we can go over coefficient. 7 is a coefficient, 4 is a coefficient right there because they're being multiplied by variables. The exponent is right there, and the constant is right there. That's the constant term right there. So let's take a look at today's lesson on simplifying expression. On this page, you can see that there are 2 expressions right here. One is fairly complicated and one is very simple. They both contain the x variable and a y variable somewhere in them, or multiple of them. The strange thing is, no matter what we replace the x and the y with, no matter what numbers, they will equal the same thing. This one over here, if we replace or substitute the x for 5 and y for 10, we get a 47. And also, if we were to do all this math over here, we'd get the exact same answer. And no matter what we replace it with, we'll always get the same answer. And that's because this big, long expression was simplified into that easy, simple expression. That's what it means to simplify. To simplify something simply says that we are going to make it simple. Right? We do that with fractions. We simplify this fraction to make it much simpler. We simplify numeric expressions and make them much simpler, even down to one single number. We can also do that with algebraic expressions, simplifying this into a simpler, easier thing. You can notice this too. This is using the distributive property. That also simplifies down to that. So let's find out, how do we simplify an algebraic expression? What are the things that we do to simplify it? Okay, here we go. So how to simplify an expression? There are 2 things that we do to simplify. For one thing, we use the distributive property. That will simplify it because one thing will look like this on the left-hand side can be simplified to look like this. So just removing the grouping symbols will simplify an expression. Also, another thing is to combine like terms, and that's what we're going to spend a lot of today on, is how to combine like terms. So let's talk about what like terms are. Combining, we know, is simply adding things together. So combining like terms, well, this is what a like term is. Like terms are terms that have the same variable. So we can see that 4x and 3x both have x as a variable, so we consider these like terms. Now let's see, why are they like terms? Why can we add these and we can't add other terms together? So 4x plus 3x. 4x means I have 4 groups of x. I have an x plus x plus x plus x. It's repeated addition of the same number. So we can kind of think of that and model it like we see here. I've got these x's, I've got 4 of them right here. They could be any number, right? Maybe they're 5. 5, 5, 5, 5. That's 20, which is 4 times 5 anyway. So this is 4 groups of x, and over here I have 3 groups of x. What happens when I put them together? I'm adding them and combining them together. Now what do we have? 7 groups of x. They're all the same types of things, and we can add them together. We can also work this out algebraically. This is what your book does. So if you're following along in your textbook, you're going to see a more algebraic approach. So if we have 4x plus 3x here, and if I were to factor out an x, this is a common factor of both of these. So think of these as 2 numbers. Like in your head, if you want to think of an example, you can say, well, what if I had if x was 5, this would be 20, and this would be 15. I'm getting these crazy things here. let me just try blue. 20 and 15. Right, if I had this, we understand how to factor out a common factor of 5, right? So thinking algebraically, don't think specific numbers, think in terms of algebra. We have x as a common factor for both of these numbers. So I'm going to factor out the x, just like this, and what do we have left over? The 4 and the 3 would be the other two factors. So using the distributive property would look like this. Well, at this point we can add 4 plus 3 and get 7, and we are still multiplying by x, and we just kind of put it behind there, 7 times x. So we can model it and see this makes sense. We can do the algebra and see this makes sense as well. So like terms, you're looking for the variable, that's it. Does it have the same exact variable? Then you can add them together and you can subtract them together. So here are examples of non-like terms. These are non-examples. So we cannot add these together. So 4x plus 3y over here, you'll notice I have 4x's, I have 3y's. Now remember, these are numbers. Could be like 4 5s, and maybe y is a different number. But if I add them together, if I literally scoot them together, do we have 7x's? Do we have 7 y's? No, we have still 4x's and 3 y's. We can't really add these together to combine them to make anything other than 4x's and 3 y's. Same thing with this one right here. I have 4x's, and then I have a constant. I'm taking 3 away, and so it would be modeled like this. I have 4x's over here, and I don't think I can move those, but 4x's, I have 3 negative 1's, and when I put them together, I still simply have 4x's and 3 negative 1's. They don't cancel each other out, they don't subtract each other. We can't really do any mathematics with those. We still just have 4x's minus 3, that's it. Over here we have x to the second power. Like this one, I'm looking at this one right here. So 4x plus 3x squareds, if I add them together, do they equal 7x's or 7x squared? No, we can't really add these together. If you imagine just adding 1x plus an x squared, which means x times x, well, that's not 2x's, and that's, or which is 2 times x, that's certainly not 2x squared either. It's just still 1x, and then there's an x squared over there. So we cannot combine these. These are not like terms. Here's an example of when we would simplify an expression. We have 4x plus 3 1's plus 2x and 5 negative 1's over here, or minus 5. If we were to rearrange these a little bit, we can use the commutative property and think of this as 4x plus 2x plus 3 minus 5. Or I like to change everything into an addition problem. If you're in 7th grade, if this is 7th grade math for you, you can change this to adding a negative 5. If you are watching this and you're in 6th grade, it's okay. You can still just keep that minus 5. Just like that. Now we can add and combine our like terms together. So 4x plus 2x, what would you get when you added those together? That's right, 6x. 3 minus 5, what do you get when you add 3 minus 5? Well, if you think of a number line, if you're at 3 right here, here's 0, and you go back 5, 1, 2, 3, 4, 5, you are at the number negative 2. So you are adding, that's that symbol right there. You are adding a negative 2. So it's 6x plus negative 2. I would, if in 7th grade, for 7th grade learners, I would go one more step and simplify this to get rid of those parentheses so that we don't have these two symbols next to each other, and just say 6x minus 2 right there. So very quickly, I want to just do 2 more examples. Here's a yes, no. Can we add these or not? X squared plus x. Can those be combined? Are they like terms? No. How about this one right here? Are these like terms? Can we combine some things in here together? Yes, we can. So if I shuffle these around using the commutative property to move the like terms together, it would look like this. Here's our terms. We have the r terms. We have the regular constants over here. And so it would look something like that. So 10r. This is 7r plus 2r plus 1r. That's 10r. And then 8 plus 5 is 13. All right, that's our video.